this thing on.
Hello, hello. Are we live? I think we are indeed. Hello. Welcome to our live demo jam. My name is Kenny Gorman. I'm the product owner for stream processing here at Cloudera and the co-founder at Aventador.
And hi, I'm Erik Beebe. I'm also a co-founder at Aventador, and I'm a principal engineer working on SQL Stream Builder.
All right. Next slide, Ashley. We're waiting for our slides, guys. All right, just a little bit about communities. I can't actually see that. That's way too small. Do you have that up? Okay, hold on. We're little newbies on this. We're going to get these slides. All right, couple housekeeping items. Thanks, dude. So there's going to be a Q&A widget if you're on On24, so go ahead and use that for questions as we go through. Let's see. You can select yes to exit the survey, and then you'll be contacted by us. And then check out the additional resources.
Which I think are linked in here.
Yeah. Yep. And also, if you're on a social platform, you're on like Twitter or YouTube, comment there. We have people watching on those streams, and they're going to relay the message to us. So bear with us a little bit on the technical stuff. We've never done so many channels at once before. So we have a great team helping us out, but there's a lot of things going on. So just be aware of that, and appreciate your tolerance of that. So let's get into it. What's the next slide there?
Oh,
we already introed ourselves.
So communities.
Okay, so let's talk about communities. We have a couple things going on here. We have the Future of Data meetup. I've done that one before. I did it with Tim Spann, if you don't know him. Awesome guy, great time. So that one's coming up. Don't miss that one. That's meetup/pro Future of Data. Also, if you've got questions that kind of following this after we've gone dark, hit the Cloudera community. We watch those things too. That's cloudera.com. Oh, community.cloudera.com, excuse me. And that is a great place to drop a bunch of questions. There's a bunch of people that will field requests and help you out there. So even after this is done, if things come to mind, hit those channels up and we'll follow up. All right, so let's talk a little bit about what is SQL Stream Builder. We're going to talk a little bit about the history of it. But in a nutshell, what we've done here is built a SQL interface that runs on Flink for stream processing. And the purpose and design for this at a high level is that teams can self-serve. They can democratize data within their organization, to use that term, even though it's somewhat overused, but really allows you another paradigm for writing stream processors that's a lot more approachable. So, throughout this presentation, we're going to talk about SQL Stream Builder and its functionality. In many cases, you can write the same thing or the equivalent in Java or Scala, but we find that development teams, for a couple of reasons, really like SQL. Number one is maybe the team doesn't know Java or Scala, or maybe even if they know those things, the wider audience in their team knows SQL better. So they wouldn't have to support a job that was written in Java. They could just support it written in SQL and have a wider support organization in their DevOps org. Those are the right reasons?
Yep. No, I think that's perfect. The idea here is that, if you're already familiar with traditional databases, you have years of experience with Postgres or MySQL or Oracle, any relational database, or really any experience with ANSI SQL whatsoever, you can dive in and build a reasonable stream in 5 minutes.
Right. Well said. Okay. So we're going to demo that from top to bottom going forward. Next slide. Okay. So, and we have just a couple more slides. This is all about demos, but we want to tee it up so you kind of understand where we're coming from. All right. So just to kind of frame what we're talking about here, obviously SQL Stream Builder is one small component of a larger framework that is Cloudera. Ultimately, it's a multi-cloud and hybrid platform for running various data workloads. So we're going to be talking about the particular piece called SQL Stream Builder that is part of CSA, or Cloudera Streaming Analytics, which is part of data flow. So you'll see the Streaming Analytics box there. We have other things like data engineering, data science, those kinds of things. So we have an awesome suite of tools from machine learning, batch, data warehousing, streaming, on and on. And we're one piece of that. And I'll show you kind of how we integrate with some of the other pieces, especially when we talk about joining batch. That's all wrapped up in our SDX layer, which is governance, security, authentication, single sign-on, that kind of stuff. All right, hit me with that poll result. All right, perfect. So we sent a poll out ahead of the demo jam, and it was pretty overwhelming. Nice to see that people wanted to see joining batch and stream data. And the Flink community has done a ton of work on this stuff as of late. We've done a ton of work at Cloudera. Obviously, I just told you about all our different components. It makes tons of sense for us to join those two types of workloads together. I'm going to demo that. It's super cool. We've done a lot of work on it. I'm very proud of it, and I can't wait to show you. So that's up first. I'm going to demo the product, kind of soup to nuts, and then we're going to talk about joining, streaming, and batch. And then as those polls come up, answer those polls, get in there and participate. We need lots of participation, please. And that way we'll know how to structure the next little bit of our demo. So stay with those live polls, help us out here, and help us drive this, because we'll show you what you want to see. All right, let's jump in. All righty, so this is Cloudera Manager. If you're not familiar, I'm going to start kind of from the top to bottom here, like I mentioned. Some of the components that I'm going to talk about today are Flink. So Flink is the core stream processing engine that we use for SQL Stream Builder. I'm going to talk a little bit about Kafka data, not too much, but just that our source is going to be Kafka for our demo. And I'll dive in a little bit on some of those details coming up. And I'm also going to talk about SQL Stream Builder. So like I said earlier, Aventador was brought on to the Cloudera family in October.
Yep.
October. And we spent the first few months integrating SQL Stream Builder into the CDP platform. And we released that March 3rd, I think. And that was CSA 1.3, Cloudera Streaming Analytics 1.3. We're now on 1.4, and 1.41 is coming like next week or something, very soon. I think it's in QA now. Is that right?
Yep. Some great improvements.
Yeah, some great improvements around materialized views. We're going to show you some of that. So that's kind of where we're at. So, you know, it's now integrated. It's a first-class citizen in the product, and let's jump in. So a couple things here just to kind of set your expectations and get you oriented. So there's three main components to SQL Stream Builder. There's the streaming SQL engine, and that component is responsible for taking input from the user, parsing it against the schema, giving feedback, creating the jar files and sending them out to Flink, that kind of I/O activity. I'm going to demo all that stuff. The Streaming SQL console is the UI or interface that I'm going to be using and typing commands into, and you'll get a lot of exposure to that here in a second. And the materialized view engine. And materialized views are an important component of the stack. It allows us easy integration with things like Grafana, Tableau, DataViz, data science notebooks like Jupyter notebooks and things like that. I'll show a couple examples and point out those integration points going forward. So those are the three main pieces. Let's get into SQL Stream Builder here. So if you had used SQL Stream Builder previously, pre-Cloudera, it would look kind of similar, but we've made some key changes here going forward. This looks like a regular SQL window. It's kind of supposed to look like a SQL window, but it doesn't do batch queries like a regular database. In a regular database, you would run a query, it would go out, it would parse an execution plan, it would fetch data from the database, maybe using that plan, maybe using indexes or something. It would return the data into a cursor, and you'd exhaust the cursor and then complete. Streaming data is different. You don't complete. The complete step never happens. The data just keeps spooling back from wherever place it's coming from, and this interface has to be a little bit different in order to accommodate that. And I'll point that out as we start to actually run some stuff. But first of all, let's just talk about our demo data. Oops, I'm not typing right because there we go. Very simple SQL statement here. Select star from airplanes. Let's kind of orient you guys for what the demo data set is, and then we're gonna run some cool queries on it. So airplanes itself is a data set that we've used for a while. It's kind of our favorite, and since we're both together here, I think it made sense to use this one because we're both familiar with this data set the most. The way this works is, and correct me on these things because Erik's the expert on this stuff. See if I get this right. Every airplane in the world should be advertising information about itself via radio frequency. And you can pick that up on the radio, and then you can dump that into a JSON format. So it's called ADS-B data, and that's being sent from airplanes live. You can just use any sort of consumer radio to pull that off. Is it called dump 1024 because that's the frequency?
1090. Yeah.
1090, 1024. Figures I get that wrong. And then oddly enough, the guy who wrote dump 1020 to 1090 is
right. Salvatore Ray also wrote Redis.
So that's kind of cool. Anyway, so that's what we're taking advantage of. That's our streaming data source. And that's what we're going to see in this demo. So hopefully it's kind of a cool, literally the antenna for this is in Erik's attic. And it's capturing the data and putting it in Kafka, and we're showing it live. So this is actual data as of right now.
Yeah, kind of the quintessential boundless stream of data, though. So it works perfect for these demos.
Yeah. Okay. So let's talk about this table. Where does this table come from? How do we define it? How are we getting? I said it was in Kafka. How are we getting it in here? So the first thing to do is go over our tables interface. We're going to go down to the table called airplanes. That's the table we're selecting from here. Okay. I'm going to pull it up, and it shows the definition box. So we can name tables whatever we want, any logical name we want, just not duplicates. We're pulling from a cluster, a Kafka cluster. We just select whatever cluster you want. You pick whatever topic you'd like to address. In this case, I'm just naming the table and the topic the same. Makes sense. In this case, it's JSON data. Like I said, we're doing dump 1090. That's putting it into JSON. I think it actually puts it into something else, and then it goes JSON. Don't we have a converter for that?
Yeah.
Okay.
That is what we're doing.
Details aside. Anyway, it's ending up in JSON format. One cool feature of this interface is that you can actually detect schemas. So in this case, since JSON data, maybe we don't know what's in there. We clicked detect schema. It goes out, it reads the schema, infers types, and builds it for us. So we don't need to type all this stuff in. This is a typical JSON representation of an Avro schema. Okay. Now in this case, I've got timestamp duplicated, so I'm going to remove that because we are going to use event time from Kafka. So we could have actually used the data timestamp for event time. In my case, I want to use Kafka's timestamp for event time. Okay. So we've got robust control over time in SQL Stream Builder. Obviously, that's very important when you're talking about streaming data. In this case, it's just a checkbox. If we had the other, if we wanted to use something that was in the data, we would simply just specify it here.
If you already have an epic timestamp in your data, it's already represented as a long. You can just put it in there; it will magically turn it into into the row time for you. If you have something more complex that requires parsing, well, we can get to that. Yeah,
we're going to talk about transformations in a little bit, and we'll talk about that. So anyway, I'll close this because it's already defined. That gives you a feeling for where that came from, how I connected it to Kafka, what data format we're in. All right, so let's run that. Let's just run a simple SQL statement, select statement, and see what we get back here. So first of all, I just clicked execute. I'm not using an IDE. I'm not in, an editor. I'm not worried about dependencies. I don't even know where my cluster is or anything like that. I don't have to worry about any of that stuff. I just need to know my schema. I need to know the data format I'm reading, and I need to know SQL. So that's what I did. I just went ahead and run that. You can actually go out here. You can click on SQL jobs. You can see I just launched it. Let's just launch the Flink interface. Like I said, we packaged this into a standard Flink job. Once it's deployed, it looks like any other Flink job. This one's, albeit, pretty simple, okay? But that's what it looks like in the Flink interface. So let's go back there. Go back to the compose window, and okay, here. So we're getting some data. All right, so this is just raw data flying in. It's boundless. It's coming in from the Kafka topic. just a couple things to point out about this data that are interesting, I think, to kind of give you a feel for like, why would I use stream processing? What's important? How is this different than just a typical Kafka consumer? So you'll notice I've got this key called iCal, okay? And you'll see duplicate of those keys. And you'll see that sometimes the data is sparse. Sometimes I'll have an altitude. Sometimes I'll have a latitude and a longitude. Sometimes I'll have a speed. It's kind of a mess. But this is very typical of streaming jobs, especially IoT jobs. When the device knows about a particular metric, it sends it. And so we have to, as data engineers, pull that data together in some reasonable picture and make sense of it so that we can, add some value to the business. So let's do something a little bit more complicated there. Okay, so let's pull up this history. And I think we'll pull up this one. So let me just stop that job. Let's talk about the power of SQL here. So you might ask, like, what SQL dialect is this? What's the grammar look like? So the SQL dialect is ANSI 92 SQL. It is Flink SQL, compatible with Flink SQL. So if you Google for it, you'll see all the SQL examples for Flink. For the most part, those all work here, which is really calcite grammar. So that's kind of the lineage of where the SQL comes from. Now, in a streaming context, SQL is a little different. We need additional grammar to help us because time matters more, window operators matter more, things like that. So here's a statement that kind of does a little bit more than just a simple select, okay? So in this case, let's just talk through it, starting from the most indented piece going outward, as one would read SQL, works the same as a database. So first thing we're going to do is we're going to define a window. We're going to partition by that key that I talked about, the iCal key. We're going to order by event timestamp. That's that timestamp from Kafka I mentioned. And we're going to take this row and the preceding two rows. Out of that, we're going to then do the first value for every one of these. We could do last value too. I think probably last value is better in this case, but we'll leave it as first. And then we're going to do some predicates, typical SQL stuff, where lat and longitude's not null, things like that, okay? So let's execute that. And again, same thing's happening. I didn't start a new Flink cluster. I didn't have to configure Yarn. I didn't have to, talk to a data engineer to deploy my jar or anything like that. It just started running it. And if we go out here, I can pull up again, SQL jobs. This Flink dashboard, the DAG for this is going to look a little bit cooler, a little bit more intricate. You can see the data flowing through it. You can see if there's exceptions. There's no exceptions in this case. It's running. You can see that it's checkpointing. I'll talk a little bit more about that in the future when we talk about Flink state and what that means in terms of availability, scalability, stuff like that. But what I want you to know now is it's a regular Flink job and it's maintaining state along the way. So in that SQL statement, you'll notice that in order to do a window over some amount of time and then calculate the first value, I have to maintain state to do that, right? Makes sense. All right, so now we're getting data back. Wow, look at how much cleaned up that is. So now I've got a simple key. I've got the first value for altitude, latitude, and longitude. This is often the first steps as a data engineer, right? Let me get a clean picture of what I'm looking at. So one simple window statement and super easy. Okay, let's talk a little bit about where that data goes, and then we can then we'll sources and syncs, and then we'll dive into the actual batch, the joining batch and streaming. I know that was the poll request, and we haven't even got to it yet, but we will in just a sec. I just want to make sure everybody understands the kind of how things work. So let's talk about sources, and then I'll talk about syncs, and then we'll show you the example. So the first source you saw me pull back was airplanes. That's defined as Kafka. Super simple. That's the 95th percentile use case. Everybody pulls up a Kafka topic and starts, running SQL on it. That's frankly, the fun thing about this. But it's also the most popular thing to do. But you can add any sort of table. What we've added as of 1.4 is the ability to use Flink DDL to define those sources and syncs as well. And so you just create, like in this case, JDBC. You just create a Flink DDL statement. You specify the table. In this case, it would be like a database table like JDBC. and I can create a new source named whatever. So super powerful. Any of the Flink DDL from that standpoint, you just specify it in this box and kind of off to the races. And that works for syncs as well. So let's go ahead, let's create a sync, and we'll just throw some of that data in there, and I'll show you how it works, because there's some schema stuff there that's interesting. So I'm going to go back to Cloudera Manager, and I'm going to use Streams Messaging Manager to create a topic. So if you're not familiar, Streams Messaging Manager is a pretty powerful tool for managing Kafka. Is there a question?
There is. So we got our first question.
I'm going to add this topic while you're asking the questions.
Is this being recorded? Yes. Yes, it is.
I hope so.
That was a good softball first question. That was not very hard at all. Yes. Yeah, we'll share that out afterwards, and you can always replay it later.
Good question. All right. So I'm just creating a Kafka topic, as you would expect, using the UI interface to do that. This is in SMM, as we call it, or Streams Messaging Manager. I'm just going to name it output KG, whatever. We don't care at this point. 3 partitions, delete cleanup policy. Super simple, pretty typical kind of thing. Now we're going to go ahead and go over here, and we're going to add a table. And we're going to pull it back from Kafka, and we'll just call it output KG again. My chair is lower for this video, and that makes it hard to type, so bear with me. I'm going to pick my CDP Kafka, where we just created it. I'm going to call it output KG. It's in JSON. Now, one thing I want to show you is, how do we get a schema for a sync? How does that work? Well, we select dynamic schema. And what that does is that makes the schema of the output equal to the schema of my statement. So I'm just going to go ahead and save that. And then let's see. We've got this job. I'm going to stop it. And I'm going to choose that sync output KG. And so the schema is going to match the results, the previous results. So that's the schema. Okay. And I'm going to hit execute. We don't have any results yet. It's just starting. Goes ahead and runs it. And while this is running, I'm going to talk about sampling. So I mentioned before that database results finish, they complete, and I would see the whole result. I'd be able to scroll through them and inspect them. And that's kind of what we've been doing for the last 30 years. Streaming data is different because the data is always moving. What would I see? I'd have to wait until the very end, and it would never finish. So how do I look at my data and reason about the data and iterate on my SQL statement? So what we came up with is this notion of sampling. And you can see it's running here. And sampling is just, think of it this way. Like, think of the stream as water through a pipe, and think of this as like a clear section of pipe where you can see all the data flowing through it. This is essentially a sample of the data that's coming out as my result set. So I can look at it. I could change. Maybe I'm seeing, like, for instance, the nulls here. I was seeing nulls before. I went ahead and created a predicate to get rid of those. So that kind of thing, it allows for iteration. All right, so this job is running. You can see it's running. Let's go back over to Streams Messaging Manager. Let's go and find that topic. What do we call it? KG? Oh, it's KG.
Yeah.
Click on that. Click on the Data Explorer, and there we go. So we can see the JSON formatted output in Kafka. Right. So that's the kind of the simplest. That's block and tackling for SSB. We talked about how to connect a source. We talked about how to detect the schema. We talked about how to run a query. We figured out where to put the results and kind of did a little calculation in SQL and sent the data on its way, cleaned it up. Now maybe an analyst or someone can see that data flowing through and make some use of it. So that is kind of the base, very, very basic overview of SQL Stream Builder. Did I miss something?
No, I think that's perfect. We talk a lot about JSON, and we use JSON pretty much exclusively for the demos, just because it's super easy to work with. But as an aside, we support Avro for serialization here as well. If you're using the schema registry already, we plugged it right into the Cloudera schema registry. If you're not, and you're just using raw ABSE files, you can provide those as well. And ultimately, you can also use it to if you're reserializing from Avro into JSON, or you have some options there too.
Okay, I'm getting the feedback that it's hard to see the screen, so I'm gonna make it a little bit bigger. If you guys want, if this looks bad, ping us on the channels. We'll try and make it look better for you. Doing my best to make it look good across all these platforms. So,
and again, if you have any questions, feel free to throw them in. We're monitoring the chat box. Happy to address them.
We'll do it like that. That's probably the best compromise I can get to there.
That looks a little better.
Okay, so let's talk about streaming batch, streaming data, joining streaming data with batch data. So let's talk about what that looks like. So first thing we need to think about is how do we get a batch source to join with in SQL Stream Builder? So in this case, what I'm going to do is I can add a data provider, and we can add Kafka providers. By the way, you can connect to any Kafka cluster. I just want to point this out. I showed you how we can automatically, and without authentication, because we're already authenticated into CDP, connect to a Kafka cluster that I have in CDP. But if it's not, maybe you have a Kafka cluster in another region, maybe you have one by another vendor, maybe you're self-managed, maybe it's a cloud provider, so it doesn't matter. As long as you have network access, we can connect to it via the Kafka protocol from this. So you would add it in the Kafka providers here. We also allow you to add catalogs. And catalogs, you just register a catalog, give it a logical name, and you can pick a type. In our case, what we've added so far, and we're going to expand this, but for now, you can add schema registry, you can add Kudu and Hive or custom. Today we're going to talk about Kudu. That's just kind of my favorite. We're gonna show a little bit of that. So you add basically in this case, I've added the local Kudu cluster, so you can see that here. Okay, so it's just my little demo cluster. Now what I can do is I can go back over, and once it does that, then you go to console, you go to tables, and it's going to add catalog types, okay, for each one of those. So in this case, it's FAA aircraft enrichment source. And what that means is we've basically filled this up with aircraft types. So now I can join between those two to enrich the data. So let me show you that. And let's just talk through the SQL real quick, and I think it'll make sense to you. And let's take out this, because we're going to talk about UDFs here in a little bit. So there's a UDF in there. I'm going to take that out. All right. So what we're doing is we're selecting the same things we did before in our last computation. But now we're joining the tail number and the model from this enrichment source, which is in Kudu. And if I go over here, I can just pull up Hue, and we can say, let's just select star. Okay, so I can select star from FAA aircraft. I can run that, and you can see we got a whole bunch of aircraft in here. Okay, so that's our enrichment source, regular Kudu database. Jump back over. Okay, so the rest of this looks like it looked before. We're just doing the same window operator, same first value stuff that we did in the previous example. But now we're going to left join against that table, that logical Kudu table, like that. We're going to specify a join condition, as you would expect. That's how it works. Just in SQL has forever. And then we're going to specify a couple more predicates on that aggregate statement. And so this is one way to enrich a table. There's other ways. We were just talking before the broadcast about the kind of the other semantics here. Right. Temporal tables and.
Yeah, right. So you have a number of options there, depending on how you want to, how you want to source the data. Another is if you happen to, your data all lives in Kafka, the facts and dimensions, so to speak. You can use version tables sourced from Kafka, which is super convenient in a lot of cases, just using the Kafka upsert connector and specifying a primary key. And let's use pretty similar semantics here in terms of the join.
Okay. Yeah. So I'm showing the basic example, kind of make the point, but that's how it works. So how this works underneath is as the data is flying through the stream, it's basically doing a lookup on key, on the primary key, which is indexed on that table. So if you're in the database, you'd see those individual lookups. Okay. So let's run that, get that started, and let's go out to SQL jobs. Pick the one that's just now. You'll also notice I can run as many jobs as I want. It has a whole pane. I can just continue to run jobs. All right. And so it's calculating a little bit here, but you can see we have a much more complicated DAG, more operators. Checkpoints should be started here in a second as the job kind of spools up. I bet you started now. There we go. And so now we have the data being captured for snapshots, for recoverability, and all that kind of stuff, scalability. Okay. And I'm sorry, my dogs are barking in the background. That was bound to happen.
Makes it feel way more live and authentic. Actually, if you wanna stop there for a second, we have another good question here. So I'll just read the question out first. Question on syncs. What are the different types of syncs that SSB can integrate with? And a specific question there is, can we dump data directly to HDFS? So in terms of syncs, Kenny, if you want to click on, exactly. So, we provide a couple of simple ways. Obviously one popular way to do this is to sync the output to Kafka. Maybe you're sourcing from Kafka. You're doing a join against some static source. You're doing a join against, a batch source. You want to enrich that. You want to mutate it in some way, and then you want to sync it to an output to build a stream on top of. We make it super simple. Kenny showed how dynamic schemas work, so you don't have to build an output schema. You can define the schema as a result of your query, and then write it directly to Kafka. But that's only part of it. There's a couple other options. You can see in the add table, drop down there. One is Flink DDL. And this basically, gives you the option of defining, any of the supported connectors, which, HDFS is an option. JDBC, anything that plugs into, the JDBC driver works as well as a host of other, supported, Flink options today. Makes it super simple to plug in.
These are just templates for you to kind of fill out and start with. It's not the list of supported. Like Erik just mentioned, HDFS is a popular one. We should probably add that to this. But
right, and the other important thing to note here is Kenny clicked on the on the cluster that's actually executing the code in the background. If you're running this in a secure environment, you're using Kerberos. These things all operate as the user that is executing the query. So if you're writing into HDFS, then you're able to use your own permissions to manage those things and interact with other components in the stack. We also have in the list there we support out of the box webhooks.
We should talk about this real quick.
Yeah, this is actually,
we don't always demo this all the time. Since you asked, we're going to go through them all. So let's talk about webhooks real quick. So a webhook sync is the ability to call an HTTP endpoint for a given output. So that data structure I showed you a second ago could be input to a REST service. Maybe it's a data science model. Maybe it's we've used it to integrate with PagerDuty, things like that. Alerting systems is one big use case. So we had one that was detecting military planes.
Yep.
And you could do a webhook sync where it would ping you if there's a military plane overhead or something like that. So super cool use cases for anomaly detection and integrating with the rest of your organization. So like hitting a mail server or a Twilio or something like that if you need to. The way it works is you basically give it a logical name. Maybe I'm just going to say it's Twilio, okay, for this case. You pick their endpoint, so you get that off their API docs, give it a description. Maybe it's asking for a post, but we can do post or put. In this case, say we don't need SSL, and we can do a template. And so the template here would be that we would essentially say what the request template is that they expect. So they would tell you this in the doc. You'd have to post these particular parameters with this particular format, and then you can just type that in here, and that way it matches. And then whatever headers they expect. Okay, so in a third-party service like that, it's gonna be well-defined. If it's your service, maybe you're more flexible or can do whatever you want. We allow for both. And then the code, you can actually have it be conditional. So in this case, like if you say true, it's going to send it for every message that is part of that sync. It's going to send a webhook. And so maybe you want to put a timeout or a threshold or a little snippet of code can be highly powerful here. So this actually was one of our engineers that came up with this, and we ended up using it with a couple customers to great effect. It's really cool, but quite different than kind of some other folks out there, and unique to SQL Stream Builder. So that's the webhook sync. All right, so those are the syncs. All right.
Yeah, I think that's good.
Let's see, were we getting results? We were. Okay, going back to what we were talking about here. So, and please interrupt us with the questions. More questions are good, and we'll just keep addressing them and do whatever you guys want. All right, so what we did, just to kind of recap this real quick, is we were running this query that had the window operator. We were joining it with this FAA aircraft table, enrichment table that had all the plane types in there, join it on a condition, and as you would expect, here's the result. So, in this case, we're getting Airbus A320s and Boeing 737s and Cessnas and a Socata TBM, which I think is a small airplane. That's pretty cool. So that's how enrichment works. It's pretty simple. The thing about that's kind of unique is that our philosophy, and I think we'll just talk about the Flink community here, and stop me if I'm getting this wrong, but in the Flink community, there's been, if you didn't know, Flink started off as a batch processing paradigm. It started off that way, it added streaming later. Over time, the APIs evolved into the data set and data stream API. There were two different APIs for processing batch and streaming. But I think the world has realized being able to do something like this in one statement is super powerful. And so the Flink community, maybe a year ago, is that right, started to transition to one API that understood batch and streaming kind of in one context. And we were excited to see that developing. We knew we'd want to go that route. And then as soon as it started to become available and be robust, then we integrated it into the product.
Right. And that paradigm is obviously super natural in SQL. And originally when you were writing these things in Java, it was a little bit less so. But the nice thing about SQL is you don't really need to differentiate between whether the source is boundless or if it
or bounded. Yeah, I mean, if it wasn't obvious, when I look in Hue here, this is a bounded data set, right? It said, query complete, and it finished. Over here, this is just the sample of data that's, I can just sample it again. That's the sample of the data flowing through the stream. So I'm effectively and quite easily here, naturally, and you can see the data coming back, joining Kafka and a batch source in a very robust way. This is interesting in the context of your overall data architecture because everything, so this is sort of a controversial topic, but there's been a lot of banter in the last couple of years about, everything is a stream really, and everything should be in Kafka. I get that, I get the conceptual difference. Every data set in the world is essentially bounded, and the only reason it's unbounded, the only reason it's bounded is because humans made a boundary on it. I get it. But the reality is that most organizations have bounded sets. That data is stored somewhere and it needs to be used. And so it's not a theoretical thing, it's a very practical thing. I've got data in this database, I want to use it to enrich my stream. Why can't I just do that? Why should I have to put it in Kafka in order to join it? And the answer is you shouldn't, you don't need to. And that's what we're doing here. That's what this allows us to do in a pretty darn simple way. So that's the syntax for doing that. All right, are we ready? Is there more questions? Are we ready for a poll?
I think we're going to the poll now.
Oh, okay. Are you monitoring that, or am I supposed to do something?
Yeah, so you were monitoring that.
So bear with us.
Okay, here we go. I think now we can see our poll.
Poll coming up.
Have you deployed and developed stream processing capabilities within your company?
Okay, so the poll is, do we have an answer? Or is it just a good question at this point? Okay, I'll read the poll, and when we get the answers, we'll update you.
Okay. But we have to release it to the audience.
Oh, okay. So we're just learning here. The poll's coming up. So
yeah, so you should see it. You should see it pop up. So, and I think we already spoiled the question now. So feel free to give an answer, and we'll get
the next one better. Okay. What did we want to talk about with? How about I talk about UDFs real quick while we're talking about that?
Yeah, definitely.
I was right
That's
there.
A good one.
Okay, I'm gonna go back to history and let's pull up let's talk about user-defined functions. Oh, that's not the one. Is that the one? Yes. Okay. User-defined functions. So this wouldn't be complete if we didn't have some sort of UDF. And UDFs have been in the product for a while. They're super powerful. They're used in production. Customers use them all the time. They're written in JavaScript. They are interpreted language and compiled language are mixing here. We chose JavaScript because it can be compiled via Nashorn down to Java bytecode and run as a self-contained jar. So that's got a nice aesthetic to it. And everybody already knows JavaScript. I mean, or it's a very easy language to learn if you didn't already know it. So to do that, you go up to functions to write one. I've got one here. We'll just talk through this one. This is basically the distance from the Austin airport. Okay, so I told you about the airplanes flying around that we were trying to measure or show the data. In this case, I want to measure how far are they from the airport itself. And so again, language JavaScript. I'm going to output a string. Maybe these should be integers if we're doing distance, but for sake of argument, we'll just call them strings.
Simple for
yeah, keep it simple here. And it's taking two strings as input and outputting a string. Okay, so the calculation is give me a lat and a long. I'm going to then perform the haver-sign formula on it and measure the distance between wherever they're at and a fixed point, which is the Austin terminal, I think. And then it's going to return that, and here's how we use it. Okay, so we give it two inputs, it returns the output. It's kind of that simple. JavaScript is supported, and Java primitives are supported. So if I wanted to say java.lang.whatever, I could do that in here as well. So very, very powerful. And let me show you how that looks. So here's how you call it. Now, it's super important to mention, I didn't define this, like I could have defined it just now and said, okay. I didn't have to reboot, recompile, redeploy, make new jars, new dependencies. None of that stuff has to happen. You type JavaScript in, and then when you hit execute, it runs. So so not only can you get instant feedback on the SQL, but you can get instant feedback on the SQL plus the UDF, and that's super important in the development lifecycle. So let's go ahead. I'm gonna start a new job on this one. Just to kind of see what good. There we go, and execute that. So anybody want to predict what the results are going to look like? It should hopefully has a number as a string.
Actually, you know what? While you're doing that, you want to answer a couple of questions here. So there are a couple of good questions we got that we're going through here. So one is, does this work on existing tables in HDFS, e.g. a history table, or do we need to create a separate stream table to stream SQL to work? And just so you know, if you're putting in questions too, Tim Span is working super hard behind the scenes here to impart his great knowledge on these things as well. So the answer for that is sure, you can use any of the tables that are in the Hive Metastore today or Kudu. And I think we actually have a demo lined up where we're going to do a join against a Kudu source. Does that sound right?
I already did it.
Okay. We already did that, apparently.
Yes.
And it worked.
It's right here. Let's do it right now.
Oh,
that's it right there.
In fact, we're doing this right now.
I anticipated the question.
Right. Yeah, accurately predicted that. So great question. and happy to drill into that more. Another, can you join based on values?
Yeah.
So short answer, yes. And I think we're doing that either in this query or in a previous one. Sure, you can join on, you can do any, at this point, you can do basically any normal SQL join, full outer, against, any
I want to show you, I'm going to go to another, there's another join in here that, that does a crazy, let me go back here. There's a crazy join here. Let me do a nest. I can show you like a good example of it. I'm just going back to some of my crazy crazy stuff. So you can cross join like this, nested data type nested structures, which is really important. There's some other ones in here that are amount based. You can see here where that gets expanded, where we unnest. So you can mix and match the syntax like you would in a database. It's super powerful. That's the best examples I have, super handy. Is that the whole question?
Yep. Someone also asked some more specific questions around JBC and supported database types and things. In this, we've linked one of the docs for SSB. We'll share all these things afterwards too. So
today, MySQL, Postgres, Oracle?
Today, so at the very least, MySQL and Postgres plug in pretty straightforward. Some of those things include a little bit more nuance to it. So we'll for those we'll share the docs, and we can definitely talk more offline about the kind of the ins and outs of the how we support the other options. But great questions.
Yeah. All right. Any more? And I'll just address this, and then I'll jump back to talking about this.
No, I think we're good for now.
Okay. And the poll, did we
Let's see. Okay, so we've got the poll results here. Can
All
we
right.
show the poll, or do we just say the poll? Have you deployed and developed stream processing capabilities within your company?
Here, read it out nice and clear.
Yeah.
And
So
nice and slow.
so have you deployed and developed stream processing capabilities within your company? So short answer: 2/3 are yes, 1/3 are no. So it sounds like a lot of people here already have at least some experience with these things, and for a smaller group, this is all new material.
Right.
So feel free to throw out questions.
And so just a couple of things on that, like deployment architectures and that kind of thing. Okay, yeah, so the polls are on 24. So that's how people are answering. So just a couple notes about like typical deployment architectures, just as because we mentioned that. So I don't know how most folks are doing it right now in production, but we see kind of a couple different profiles. First of all, is people already have Kafka, they already have an investment in Kafka. Now they're just trying to make sense and value out of it. How does this work, and how do I get how do I get the data out and even understand what's in there? And then how do I deliver it to some destination? It's very common to take it out of Kafka, do some sort of stream processing, and then put it into maybe a database. Like that's kind of the most simple use case. If I had to guess, I bet you 80% of folks who are in production are doing something like that today. Maybe some real-time ETL-ish kind of stuff, or maybe some like data cleansing stuff, that kind of thing. Very, very common. And then the tool, whatever tool, dashboarding, Tableau, whatever, looks at a database. And that's like the first flow. And maybe what we should do is talk about that materialized views right now and talk about how we can kind of change it up and make it more powerful. But that's kind of number one. Number two is you're all in on the Cloudera stack. You are deployed in production with Cloudera. Now we have another option you can do there. Let's say you're all in on Cloudera. You're using Hive and Kudu, maybe the data warehouse stuff, maybe the data science stuff. And you're like, okay, I want to add in SQL Stream Builder, CSA, as we called it earlier in the presentation, Cloudera Streaming Analytics. But how do I do that with like dependencies and stuff? And there's a super easy way. All you do is, it depends on you. It depends on what kind of control you want and what kind of deployment topology you want. But you can deploy a separate cluster in SQL Stream Builder and CSA alongside that, and then tap into the Kafka, tap into Hive, tap into Kudu via the APIs. So it doesn't have to live on Cloudera only in order to make use of it. So you can connect, a self-managed Kafka to a self-managed Hive, to your own Grafana, to the Cloudera Kafka, all that stuff. So we really tried to make it as flexible and useful as possible within your org, so that you don't have to pick and choose all or nothing. You can get the value for SQL Stream Builder no matter where your data is kind of coming from or going to. The most common use case is I'm going to put this in Oracle. Well, we don't manage Oracle for you. Oracle does that. So how would I do that? And you'd use, JDBC or something like that, right? So that's kind of the typical topologies and typical deployment paradigms. Should we talk about materialized views and show the Grafana stuff?
Yeah, let's definitely do that.
All right. Let's just jump in here. I'm going to go ahead.
Oh, I was just, while you're getting teed up for that, another good question here. So let me read it out here. So a question on windowing. When we say rows between current and 2 rows preceding, what would be the time span it would wait for so that the row count will be appropriate to do a window? So that's a good question.
Very good question.
And it's important to the way that you craft queries in in SQL Stream Builder in particular, and in streaming environments in general. So windowing in this particular example doesn't specify any sort of time window. In this particular case, we just because of the source data, we already know what to expect with that. But in most cases, when you define these things, you'll want to define a actual chronological time window. Using things like a tumble window or hopping window, whatever makes sense for your particular environment. Both for the reason that you want it to be relevant to the time period that you're evaluating, but also so that you can limit state collection for these things, because it is possible to craft a query where the accrued state for that becomes both massive and also not particularly useful. If the data that you're interested in is basically for the last 5 minutes, but you're evaluating a stream that is much larger than that, you'll want to make sure that you bound that stream, with some sort of windowing directive, to control those things.
I was trying to type what Erik was talking about with actual SQLs while he was describing it, but so there's a number of window capabilities, not just the preceding window, which we were showing because it was convenient. Including tumble, hopping, session, and custom. Custom would be something you'd implement in Java, so not within SQL Stream Builder. Did I get all that right? That's from memory, so be warned. Okay, so and this is the syntax for that, if you can see on the screen. So I just pasted this in from my other little scratch pad, and you can see I'm doing some things here, right? But for the most part, I'm choosing a tumble window based on that event timestamp, which is in this case, again, Kafka timestamp. I'm specifying a window of 1 minute. Then I'm summating, I'm casting size as an integer. Then I'm summing it and counting it over that window from this logical table called KG, or my initials. So just as a quick, dirty example of kind of another type of window operation. That's a great question.
I'm glad you had this one teed up too. This is a good.
I had to copy it from other things.
Perfect.
Okay.
And these, so obviously, you can, again, any, the normal things that you're used to in SQL are largely supported here. Some of the semantics are different, but you can build, windows, window over, partition by inside of these queries, in subqueries, etc. Some of those require tuning for your specific environment, but Kenny's example here, I think, is kind of a perfect add-on to that question.
That's a good question. I like that involvement. Okay, so I have no jobs running here. I just click on the SQL Jobs tab. I don't have any jobs running. So let's go ahead and create a materialized view, and let's talk about what that looks like. So let's just pick this one. Okay, so let's just talk about materialized views real quick. First of all, it's a tricky topic because materialized views are overloaded in the data engineering and computer science world. They mean a lot of different things in a lot of different contexts. The materialized view I'm talking about here is, like I said earlier, what we're doing is we're taking any result, we're picking a key, and then we're keeping the latest status or latest state, latest value of that result set by key. The reason this is important is most calling applications require A, that kind of a paradigm, and B, the ability to have their cursor finish, right? So Tableau, I'm just gonna use that as, I'm gonna pick on them, or Grafana, we're gonna show Grafana, so maybe I'll do that, expects that your cursor would finish like a normal database query. Obviously, you can't just point Grafana at Kafka without some sort of sync or some sort of connector and make that possible. It doesn't understand the consumer semantics and a boundless string. So materialized views give you a tool in SSB to materialize the end of that stream in a way that calling applications can use it. So another way to look at it is this query right here is a push query. Okay, and other software packages call this a push query. Now let's configure a materialized view, and I'll show you a pull query. So first thing first, we click on materialized view tab. We pick that primary key that we're going to save the data by, that we're going to aggregate and save the latest state, or save the latest value by. So in this case, it's that ICOW number. You give it a retention seconds. Now, this is important. Everybody says, like, what should that retention seconds be? And the answer is sort of like, it depends. One example I was just talking about was customers are saying, what if I want to record everything that's ever happened to my enterprise and save that to some place? Is that a materialized view? The answer is no. You probably want to put that on HDFS or database or whatever cost-effective platform that makes sense for you. This is designed, like I said, to power something like Grafana or a data science app or whatever. Something where the data is bounded in its very design and where that boundary is not massive. Now, we have customers running this production with billions of events a day, and they're using this paradigm to use Tableau and Grafana against it. It works great. And so let me just continue and I'll show you. So in this case, maybe I give it a pretty long window, retention seconds. I can configure this to recreate on job start. In this case, I won't. So that means the data is not retained between restarts of Flink, or it is. I can ignore nulls. And why this is important is imagine if my latitude and longitude was coming through as null 50% of the time. I wouldn't want a null value to update it where I had a value. I'd want to know that latest position. So this is a nice handler for that kind of condition, very common in like IoT use cases. Give it an API key. I can apply that. Apply that. Now I can add a query. And so this is that pull query I talked about. And I'm going to configure this as a REST query, but it's also available via the Postgres wire protocol. So let's just say airplanes, and I'm going to select all the columns. So this is, again, that pull query. These are the columns that are going to be returned. I can also add a filter. So maybe I wanted to say where tail number is not null or something like that. I could also add that here. One other thing I can do is I could actually add a predicate here. I could say, I could pass in a iCal key here. The reason this is cool is this allows you to build drill downs. So you don't need to worry about indexing. This isn't just fetch by key. You can fetch by any column that's returned in this result. And you can pass in a key. So let's say in the airplanes example, I'm making a map, a Google map, and I want to see all the airplanes around, and then I want to click on one and get more data. This would allow you that entire drill down functionality right within SQL Stream Builder. So pretty cool option to kind of have there. Did I get that syntax right?
Yeah, and it's also ideal because these more or less work like views. So you only really materialize the data once. You're only paying the price for doing it once. And if you want to represent it in multiple ways that are kind of read optimized for the application, makes it super simple.
Yeah, good point. Like I could do one that's generic, like that has all the airplanes, and then I could have another one that just picks one, right? Yeah. Oh, actually, that's nice. We added that little mismatch thing. I didn't know we had that. Cool. Nice work. All right. And then let's just not do that part of it for this. And we'll save that. And we get a durable URL for that. So you can think of this as a durable REST endpoint. You can share this in your organization. One use case that this is really powerful for is data science. So imagine you're in Pandas in a notebook, and you want to pull in this data, that's a pull query, into your data frame and perform some analysis in it. Or maybe you want to use this to invalidate a model based on data skew. This is the kind of thing. So you could actually have your app reach out to this URI, get fresh data, and decide whether or not to invalidate based on skew or things like that. So that's a use case that's super cool here. And if I run the query, it goes ahead and creates that endpoint. Now, let's talk a little bit about things like Grafana. Let me find my, okay, so here's my Grafana graph. This is just regular Grafana. I'm running it as a container. It's just, kind of add on. This is a regular Grafana instance. There's nothing super fancy about it. Let me show you the SQL that we're using to create it. So here you can see we're doing a pull query from that source, just like we did a REST pull query. We can also do SQL pull queries. We're doing a little bit of date formatting here. We're selecting the model of the aircraft, that enriched source. Then we're counting them. And then we're picking, again, nulls and some processing. We already did this. This is just to kind of show you can. We're grouping by time and the model. And we're saying where count is greater than 4. So just to kind of filter the data down. And we're ordering by time. And now we have this cool report of what aircraft and how many of them have been flying over based on any sort of given time frame. So super simple integration into something like Grafana. I can show you here the data sources. You simply just connect to, in this case, Postgres protocol, just like you would any other database. It just doesn't matter. And then you can start pulling back data via SQL. So kind of 2 steps there, just like you would use Postgres. Now, the implication here is kind of interesting. I didn't need, so another alternative way of doing this would be to take all the Kafka data, however many events per second, create a connector, maybe it's K-connect or something, and then put that into a time series DB, okay, like Influx. And then Influx has 100% of that data, right? I didn't have any sort of stream processor, aggregator. So it's that messy data I showed you initially. Now I've got a problem in Grafana trying to unwind that messy data. And it also has to parse through all that messy data. So very large footprint in, say, Influx. Here, I didn't need to do any of that. all I had was a simple materialized view. I wrote a push query to pare down and process that fire hose of data. I wrote a pull connector so that I could connect to Postgres. And then I was in here in Grafana, and I wrote the most simple SQL statement just about possible, just to pull back that data. So you're really taking the burden and performance problems away from Grafana or Tableau or anything else, pre-processing that data to the stuff that has value for your use case. Then you can go in via Grafana or Tableau or DataViz or notebooks or whatever, and then be dealing with a manageable and usable data set. Did I get that right?
Yeah, great.
Yeah, cool.
We have time for a question real quick.
Yeah.
So here's a good one. If any field in the airplane, say, has JSON data, can we create a materialized view and perform some filtering in that JSON data? So this is actually, so yes, is a short answer. So the great thing about this is, when Kenny first started digging into this, you can kind of see that, the airplane data that we're using as the demo is serialized as JSON that we've assigned a schema to. When Kenny first set up the topic, he told it to detect the schema. It duck types the data that exists in JSON today, assigns types to it.
Sorry, I'm behind. I was supposed to follow along. Okay, go ahead. Sorry.
And the thing is, the airplane data that we're showing you right now is fairly flat. It has a bunch of top level keys. It has and types assigned to those. We also support if this was nested data. Say, for example, one of these keys.
Do you have one? Do you have one at console? We're gonna bear with us. We're gonna find one for you. We're gonna try to here.
Right. One of these may actually have some amount of
nested types. Yeah, we're doing this live, so this might be fun if you guys just. Oh, BGP has it, right?
I believe it does. Yeah.
Yes, there we go. All right. So we're gonna explain this data source now. Yeah. So this is BGP data. If you're familiar with this, is network packets that are flowing. This is a different use case. Okay, so we're just switching it up because you asked a question. This is BGP data that has nested types, and you'll see that the definition actually has it defined as such. I bet you there's SQL for this too, isn't there?
There probably is.
We're gonna go out on a line.
Search for BGP.
We're gonna go out on the limb here since we're GP.
Here we go. Yes.
Oh, that one's not that good though.
No. Look for. I bet there's another one with an on nest. There we go. Perfect. Okay, so two things about this. So, in this particular example, the document is a JSON document, and the JSON document contains basically an array of JSON inside of it. So there's a couple of things that you can do here, in answering that question. And one is what Kenny just showed you. You can unnest those array items. And basically, every one of those array elements turns into a row of its own that's evaluated separately. And so you can filter on top of those just like you would any other SQL query. You can add, you can add your own predicates, filter them out however you'd like. If it's a well-defined array, like in every example, like there's the JSON field contains an array that contains two elements, then you can specifically pull that element out of the array, remembering that in Flink SQL, array elements start at 1, not 0. But you're able to pull those out directly.
So I was pulling another example here. I'm just pasting these over. So I'm jumping between different example windows here. So bear with us. But here's another example of how that looks. So I can actually pull out nested values like this. Yes. I can use them in my, there's no predicate here, right? But I could also say, I could essentially put a where clause in here, right? I could say, let's just do it like this. Okay, something like this.
And if that's still valid, go over to the materialized view window real quick, and then let's see if that gets.
Probably because we don't have the right.
Oh, I think we've got two queries.
There's two queries in here, and we actually don't have the sources in here.
Right.
This is just Scratchpad.
Yeah. So
none of this is going to work for you. I'm just showing you what the syntax looks like. We don't have it. We don't have these tables or anything set up like that right there is not valid. That's what I would do.
Right. We have to do at least a couple things that don't work to keep this authentic. But the the idea here is that you can see select data.order.state. You can drill into those into the the sub fields inside of a nested document directly by name. And when you assign an alias to it, like in this case, you can see in Kenny's query, select data order state as state. All those things will be available to the materialized view when you build it as columns that get built into the view itself. So long story short, yes, absolutely. You can kind of filter it in two different places. You can do it in the streaming query itself, and also reshape the data to the way that you want it to look in the materialized view. And when you build a materialized view, you can use the filtering that Kenny demoed a minute ago to add additional filters around those fields to kind of tune what you want that view to look like.
Yeah, that's a great question. The story there is that we were both. It's harder to do nested types like this. Like the nominal use case is to do just unnest and flatten everything. And a couple of things happened there. One is we were passionate about being able to use complex types and nested types. Our background is in database engineering, goes way back, but also we have did a 10 years from a MongoDB perspective, and Mongo taught us a lot of that value and the kind of unstructured data and JSON as a first-class citizen and that kind of stuff. And so when we built this, we really wanted to have that aesthetic because essentially there is data, metadata in structure. That structure matters. And so we didn't want to always assume that the customer had to flatten those structures. We wanted to provide as much tuning as we could beyond that. And this lives through in the materialized view. This flows through. So that is a really good question.
Yeah, this is actually, it's a great, if you spend your days wrangling JSON, as many of us do, like these are actually, we spent, a lot of time trying to, to add the, add helpers here to make it more navigable and easier to drill into. Yeah, so great question.
Yep. I like that one. All right. What was I doing? I lost my train of thought here. Any more questions?
I don't think so.
We talked about UDFs. Should we move on to input transforms, or?
There is a couple of the questions here are and I'll kind of batch these together. Are basically, how does this compare to a number of other streaming SQL engines? How is this better? How is this different?
Let's do it. Let's do it head on. I'll do it. What are the ones? Do they name them?
I think KSQL is probably the most popular one.
So let's talk about that. So we just talked about nested structures. That's an important one to keep in mind when you're thinking about the ecosystem. So I'll talk about the ecosystem broadly. We won't name names here, but in the ecosystem, when you're thinking about this kind of thing, there's a couple of products out there that have a similar kind of aesthetic. You should check them out. They're great. That said, this area of work, SQL processing, SQL on streaming data, materialized views, that's a pretty exciting and changing piece of the streaming ecosphere. That was one that excited us early on when we kind of got into it. We've been doing this for a couple of years now with just SQL itself. So, good tenure with Kafka, good tenure with Flink, and then added SQL in the last couple of years. And then now at Cloudera, we're really, going gung-ho with it, to be honest. So one of the things there to think about is kind of as you form your opinions about this, if I just was going to give you advice and chime in with whatever you think is appropriate here or whatever I get wrong, is number one, those nested types are an important piece of it. Like I just said, structure matters, and having to unnest or flatten everything, it's frustrating. And you created data structure for a reason, and that matters. So why are we making you unwind that logic? We don't want to. So that's one of the things. The other thing is I'll point out that I think is very powerful here is the notion of materialized views. There's actually two more things. The notion of materialized views, it's not just a single key lookup. I showed you that variable in materialized view where you can specify, can't do it right now, where you specify the key. It doesn't have to be the primary key. It can be any predicate, and that's indexed in high performance in Postgres from our side. So you don't need a DBA. You don't need, there's not a lot of limitations there. It allows you to drill down like you'd want to drill down. So if you had an attribute by plane called color and you wanted to drill down by color, you wouldn't have to create a whole new transformation for that. You could just, where color is the key, you can just drill down on that. It would be high performance. So that was important to us as well. And then lastly, the way this system is set up, you'll notice, and we're just going to go back here, the Cloudera platform brings some niceties here. Number one is we're running Flink and SQL Stream Builder as two different clusters, okay? So it's of their own resource, but also Kafka. And so if you want to scale Flink, maybe your computation is performing some particularly tough logic, or maybe that UDF is, particularly high compute worthy. You could scale Flink without scaling Kafka. So your processing tier or tiers could be separate from your event log tier. And I think data engineering folks will appreciate that. And vice versa. So if Kafka's scaling because there's a whole bunch of stuff going on over here or over here, other consumers for other reasons, you don't have to be taken along with that to scale your Flink side. You can simply scale it to whatever purpose at hand. The way you do that is under advanced settings, you would just pick a job parallelism. Now, you might say, what does that do? Well, it creates a parallel thread for Flink. That's a typical parameter for specifying a Flink job. We just pass that along. That's not anything special there. And one thing to think about when you're doing this is you're probably going to want 1024 partitions if I launch it in that way. So you could outrun Kafka if you got too aggressive here. But if you follow good Kafka practices and have enough partitions, then you should be fine.
And the great thing about this is, at this point, Yarn, handles all the heavy lifting for you. Users don't have to think about,
right.
the scheduling aspect of it. Basically, you can define parallelism. You can, build, effectively a keyed stream of the group by, and at that point, as long as you have enough partitions to, to source it from, you can make a job that scales super easily.
Yeah, because the alternative is imagine that we had some like big fraud processing flow here, and this was detecting fraud for our organization. And imagine that we wanted to scale this computation like up. If it was based on Kafka, if it was intrinsic to Kafka, we'd have to actually scale those number of partitions. And that means we're going to have to move data. And so we actually have to change the topology of our Kafka cluster in order to accommodate the processor we want to write. We don't have that problem as from the Cloudera stack and using Flink. We have separation of concerns between the event log and the processing tier. So I think that's important and key when you think about these things. Those are the big ones in my mind. There's a bunch of other little nuances that I think we're proud of and I think are awesome, like input transforms. We're going to talk about input transforms, I think, in a little bit. So I'll save that for later, but I'll point out that when you go to tables, and we have one here called transform, there's actually an input transformation that can happen here. That's very unique to our platform as well. And we'll discuss that, I think, in a little bit. So hang tight for that. What else we got?
That's it for questions for now.
Okay, do we want to hit up a poll? Has that poll been launched? You want to maybe send the bat signal that we should send one of those?
I think we might have exhausted the polls. Hold on, let me.
Well, there's one about input transforms or UDFs, but I think I already talked about UDFs.
Right. I wasn't. Let's see.
Okay, so I'm gonna start. I'm gonna actually just jump into the input transforms since we're there. Does that make sense?
Yeah, let's do that. We can multitask here.
Okay, cool. All right, so I just showed that. So here we go. Let's just jump into what an input transform is. So just like UDFs, input transforms are JavaScript. They're interpreted, compiled to bytecode, and sent along with the jar to Flink. Now, the important thing to think about in an input transform is they live ahead of the table in the stream. So what is that for? So a couple of things are really important here. One is that I can take that record and I can use the Kafka header metadata and infuse that into my schema. So for instance, I can add the partition that piece of data comes from, or I can take the offset that we're currently at, or that kind of stuff, and I can pull that into my schema. And I can actually, if you have it in here, did you add it?
Yeah. Yeah, the resulting field for it.
Yeah.
It's at the top.
Oh, topic. Yeah.
Topic.
So, right. So here we go. So there's a topic or a column here essentially called topic, and that is the topic from Kafka. So we can push the Kafka metadata into and make it available to SQL. This is super important because we had a use case where a customer wanted to count the size of messages, actually, and understand that as part of their computation. So that worked great. We can also parse just the regular payload of the data. And so the use case here, and I don't know, maybe you want to talk about that one customer. We had one customer that was particularly, this was super important. Maybe I'll just tee it up and you can give detail. Everybody likes to think that their schema is perfect. Like in Kafka, everybody likes to think that, oh, we produce a schema that is in really good shape in a Kafka. The reality is, or at least we found, is that when you go and you look in Kafka and you set up a consumer and start pulling it back, over time you'll find data that just doesn't match. And whether that's missing keys or nulls in weird places, or things are sometimes arrays and other times they're just text fields, it's the same name. Other times they'll just be missing data or garbage data. We've seen where people just send a ton of like bogus. Maybe there's a sensor on an end of an IoT chain that's flapping, sending garbage, like not even intelligible UTF-8 characters, crap like that. So this happens all the time. And the problem we got to was like, how do we let a customer and enable them to run SQL on a stream when that stream is junk?
Yep.
So what we did was we said, let's build something called an input transform. Let's allow the customer to write logic in JavaScript. It lives upstream of the schema, right? So the output of this transform needs to match the schema, like topic needs to exist here. And I can put logic in there. I can say like, hey, if I see this iCow number, if it's what does parseInt do? It's just parseInt as an integer, right? 16-bit.
Oh yeah, so yeah, it's converting hex to decimal.
Oh, I see. Okay, right. I see. Otherwise, it catches it and says unknown. So we can put little bits of logic in there, and that can clean up our schema experience drastically. In our experience, it's very hard to go back to a data engineer or the people creating the data and say, hey, go clean this up before I can even start my project. Like my boss has asked me to write this computation. It's super simple. I just want to get it done because I want to go home and be done with my work day. And my incoming data is garbage. And now it's a week-long effort because I have to figure out all these things. Input transforms essentially fix that. It allows you to say, like, I'm in control of what's going to be presented to my schema. I'm going to write some code that manifests that before the schema. That way my data is clean. I can make whatever assumptions I want. That gets compiled into the jar, sent out to Flink, and you're in good shape. So
yeah, we had one particular customer that was doing this. That when they originally built this, they were actually building it into case statements in the SQL query itself. So they had many SQL queries, and ultimately like the case statements were 400 or 500 lines long. In order to to normalize and detect bad fields that were provided by this third-party API. And being able to push those, up into the input transforms means that you can really kind of consider your library of sources to be pristine at that point, and any simple query against that is accurate without having to implement all this logic to clean or validate it before you can trust the data.
Yeah, and they didn't own their sources. So in this case, what they had was, I'll just make it generic. They had a bunch of listeners that were listening to public APIs. And they were aggregating all those listeners into a single source of truth. But every one of those APIs was made by a different vendor, and they had to aggregate that together and make an aggregate, like, coherent picture of that data for their business product. It was near impossible with case statements. They could not keep up, and they had to be dynamic, by the way. So they needed procedural logic in there too. And so using input transforms completely fixed that. It allowed them to say, if this thing's sending, so one of them, it's also a rate problem. So one of those things was sending 1,000 messages a second. One of them was sending 10. The one that was sending 1,000 messages a second was sending mostly crap, mostly garbage, mostly like empty strings or unintelligible things, just because of the nature of how that thing worked. And so what they could do is say, I don't even want my SQL to address that bad data. I can just parse that out here. It won't even affect my query in any way. So it reduced variability in their code base as well. So they're less bugs, more robust processors, that kind of thing. So super powerful if you use it the right way. Again, written in JavaScript, procedural logic. You write a tiny little program that will help clean up your data and present it in a nice way to your schema. We thought a lot about this. We thought about how do you take the best things of a very structured world, a very structured schema like SQL, and the current desire to have unstructured data, and how do you mate those two? And I think you've seen us embrace nested structures. I think you've seen us embrace kind of input transforms of data cleanliness, and we've tried to and things like detect schema in JSON. Really tried to allow you, like if you send a stream from Mongo right now, it's just a Mongo stream, we can make use of that. We don't have to flatten it out. It's kind of that simple.
Yeah, definitely.
Okay, what else?
Yeah, so I think we published the poll.
Oh, cool. So the poll was like already input transforms. Why we're talking
right.
about?
It was. I think we coincided nicely with the poll. Good news. We'll cover both.
We're ahead of the game here. Yeah. So if you have questions about input transforms or materialized views, I know those topics are sometimes that generates a lot of questions. So post them up there. Help us out here. Get some questions in there, and we'll answer them. So. You got anything?
Let's see. Going through questions here. Here's a good one. So is there a hardware limitation for parallel threads? Does it relate to cores in the node? Yes and no. So obviously, from the walkthrough here, the idea here is that this is as serverless as possible, right? You want to be able to to think in terms of logic and SQL, and not so much about cores and scheduling. And that's one of the things that we really love about Flink is resource management is super transparent and is is very easy to manage. And in this particular case here, you can see in Kenny's Cloudera manager cluster here, we're running Flink on top of Yarn. Yarn has dedicated pools of resources. So ultimately, the answer there is, yes, as you scale this up, it's using, it's consuming cores, it's consuming memory on those, on those nodes. But it is, it's relying on Yarn to do those things. So assuming that you have, a Yarn architecture that, handles this appropriately for you, the answer is that, it'll scale as far as you continue to have resources for it. The question around, threads versus cores, no, it doesn't, there doesn't have to be a one-to-one relationship with that. And in many cases, there's a good, there are good reasons to not, and to have, the number of, running threads compared to cores oversubscribed depending on the workload. And in many cases that kind of depends on your specific needs and your specific Yarn configuration. If you have kind of specific use cases around that, or specific questions, or you're already running an environment like that and you need more information, definitely ping us and we can go, a little bit deeper around, what normal looks like there, and what might make sense for you too. Yeah,
we have actually a sizing guide. So just kind of to level set, we have an amazing SE team, an amazing SME team, which I think Tim's on right now. We have sizing guides for Flink, so we've got both a kind of a best practice configuration doc. The team, just so you know, that one of the things that excited Erik and I about Cloudera, just to full disclosure, is that there is an amazing talent pool of folks that know a lot about Flink itself. PMC members are on staff. We have a ton of Flink interest, community, participate in the community, and that is super exciting. So we have really good documentation around like how to size things, best practices, stuff like that. So it's SQL Stream Builder is essentially a really nice way to use Flink, but ultimately we're using Flink. And so, that's and we have a great team of folks that know about Flink. So from the support structure at Cloudera all the way up, I don't want to sound like too much of a sales pitch, but we were blown away. And one of the reasons we really wanted to be here and do this is because of that. It's awesome. So great folks, deep chops, good bench strength on the Flink side, and now the SQL Stream Builder side. So.
Definitely. Yeah, the team is suggesting that we start to wrap up.
Oh, okay. All right. So let's do this. Why don't we? So if you have any further questions, we're going to start kind of wrapping up here a little bit. If you have any further, the questions so far have been amazing. So keep those coming as we kind of wrap up. If more pop in, we'll jump on those and keep going as long as you want. Number two is just want to kind of go over the high level discussion that we had today and just talk about things in general. And I'll tell you about a couple roadmap things. So bear with me for a second, and I'll get a couple roadmap things out there that you guys are going to want to hear about, and then we will say goodbye. So a couple things. One is I showed you that really high level flow. It's super simple. Kafka in, Kafka out. Define a schema, auto detect it, run some computation in SQL, window operator, group bys, all the kind of stuff you'd expect in SQL, the kind of stuff you've done before. Pipe it into a Kafka output, and that is bread and butter, super easy. We talked about some of the power that the SQL dialect has, window operators. We didn't talk about match recognize, but I'll just mention it here. Match recognize is a very powerful extension. It's written in SQL, and it allows you to do deep CEP. The use case we were going to show is, in fact, I think I even have it. I'll just show you real quick. Match. I won't run it or anything. Oh, I don't think I have it, actually. Oh, I don't have it. Okay, that makes that easy. Match recognize allows you to do deep CEP on top of SQL. And so if you, like, for instance, want to see planes landing and you want to see that progression from step 1 to step 2 to step 3, that's actually a lot of logic in Java, and match recognize allows you to just write that in one statement. So it's very powerful. We talked about UDFs and how easy those are on the fly to define. JavaScript is language, high performance, super functional. We talked about input transforms a lot, how to make data look good on the input. Again, written in JavaScript, super useful when you don't control the schema, or you do and you know it's a mess. It's in your control as the person writing SQL, not someone who's publishing the data or someone upstream. We talked about materialized views, showed a little bit of Grafana. I didn't show Tableau or data viz or data science notebooks, but hopefully you get the picture of how those things all connect. You have a REST endpoint, and you have a Postgres endpoint that you can connect to, super easy. Materializes the data by key, presents it in a pull query or a consumable way that you can use to add business value downstream. Talked a little bit about sources and sinks and the different ones. We have Flink DDL, we have catalogs, we have Kafka, we have webhook, so a bunch of different ones. And I think that's it. That's what we covered. So looking forward, let's just talk a little bit about roadmap, how we see this evolving over the next, I'm not going to tell you everything, but there's a couple of cool things that I want to put out there. Number one is change data capture. So there's been a lot of talk around how can I capture change from a database and make that a stream of data. The current state of the art, or a current way to do it, is to use something like Debezium and pull it in from, into Kafka and then read it into something like Flink. Or maybe you just have a connector and you put it into a database or something. What we've done is we've actually, and this is an open source project, we're now part of that and contributing there, pulling that in to Flink itself. So you don't actually need Kafka between you and that source. Flink can detect that change and immediately act on it in SQL. It's a huge unlock because normally 100% of that change gets put into Kafka. And then you have to read 100% of that data into, say, SQL Stream Builder and process it. What we can say is on fetch, provide that SQL statement, like where X equals Y. You don't even see the changes if it's not matching that SQL statement. So you can drastically pare down, focus on the data that you need to see in that database and not have to see the full change stream. So that's a very powerful and high performance way of implementing CDC. That's coming. We have that in dev now. It's looking good. If you want to see that one-on-one, happy to show it to you and demo it to you. Give us a shout out here on the links, and we'll get you in touch with someone if you want to see that. Also, I think it's worth mentioning Kubernetes. So Aventure has a long history with Kubernetes. When we came to Cloudera, we integrated with the Cloudera platform, and then now there's a roadmap towards Kubernetes across the board, and we are on that roadmap, and we'll be releasing. Right now, this is Yarn. I showed you Yarn-based stuff today. SQL Stream Builder has run and is run on Kubernetes as well. And we're doing work now to integrate into Kubernetes going forward on the CDP platform, both cloud and on-prem. And then soon we'll have a release on our Data Hub platform, and that will be 1.4.1 of CSA on Data Hub. And that's coming up pretty soon. I don't want to release beans too much on that, but look for that. That's going to be super exciting on the Data Hub platform. So, any more questions? I think, did we cover everything?
I think so.
Wow. Okay. So this has been super fun. This is the first one of these we've ever done. I actually thought it was really fun. It's more fun than normal. Great participation. Thank you so much for all the people that joined. A ton of people online watching. Thank you very much. If you want to find out more, we'd love to talk about this stuff all day, all night. So connect with us in the channels, and we'll get you set up with someone and get connected. Anything else?
No, I think if you enjoyed this, we're happy to do other topics. I think we probably already have a couple in mind. If you have suggestions, feel free to ping us and let us know, and we'll put some more of these together. It's a lot of fun hanging out. Yeah,
that's awesome. Okay, guys, thank you very much. It was great hanging out, and again, appreciate all the attendance. It was awesome.
Cool. See you guys.